Arrays, what kind of arrays?
Location arrays? X and Y
Location
coordinates?
Probably
Like coordinates?
Do you suppose that this screen, this one, is a two-dimensional or a three-dimensional array, standard array?
It's probably two-dimensional.
Two-dimensional.
Yeah.
Is it in full resolution, which is not right now, we dropped it down to accommodate the overhead, but in full resolution it's 19 by
10.
10, 20, 1080, something like that, for one of them. And then it's 32 bits deep as far as the resolution goes, color resolution. So, I don't know, I haven't computed those kinds of numbers in a while, but you can take 4 bytes times 1900 times 1080 and come up with some rather large number that's larger than what I have on my machine. Okay, and we're constantly updating that. Does every pixel in this screen change every refresh cycle? Doing this, say, 120 hertz, okay, or even 60 hertz. Not every one refreshes. What refreshes? Only those areas that are changing, right? So inside the card, inside the graphics card, we have a dynamic array, a dynamic two-dimensional array. Sometimes we call it a display list. It's one of the ways to make more efficient and more economical the refreshing and displaying of information. Actually, there's a lot more than just that going on in these two scenes, but nevertheless, in order to display, we have a frame buffer, but that frame buffer is traversed 60 times a second, or 120 times a second, in order to keep the image smooth and our eye isn't doing some weird thing where you've all seen the old movies from the 1910, 1920s where they're flickering, because the refresh rate back in those days was about 16 frames a second, and we can see that. Our eyes are able to see it. So we have to traverse this very quickly, and we traverse the array of things. It's a dynamic array, just like what we've been talking about, where we have an array of pointers. What do we point to? Not character strings, not character strings. Most of the time, we're going to point to a function, okay? Or maybe even a series of functions that then execute. Is that clear? So, as they execute, now, this machine runs, I don't know, a couple of gigahertz speed for the CPU, for the main CPU, but most of what's going on here is actually on the GPU, right? It's on the graphics processor, which is keeping the display refreshed. That's my point. Bringing this in is to show you that yes, indeed, the stuff we are working with has literally thousands of different applications. We're doing one that's very, very trivial, quite frankly. Very, very simple application. This dynamic two-dimensional array business, ragged edged array, where we have an array of pointers to something else. Sometimes it is a list, sometimes it's a string array, sometimes it's a list of function pointers. Why in the world would we ever want to do function pointers? What are they? If you looked at chapter 12 material, towards the end of chapter 12, there's a discussion about function pointers. Why would we want to do it? Any ideas? No? Well, let's take a more immediate thing. Some of you are going to be taking 136 next term. Some of you will be taking it next year. But whenever we talk about polymorphism, what is polymorphism? Tyler?
Polymorphism is when you have functions with the same name, but they do different things.
And so we call one function, we call string copy. And I've already had you write at least 2 different versions of string compare, right? And we could write, you can think of a lot of different versions of string compare that would do pointers or do arrays or do special things, all uppercase, all lowercase, lots of different versions. They're not all the same function, obviously, but somewhere in there is a pointer to an array that has all of those function names in it. So that in itself is a pointer to each one. We select which one when we do polymorphism. We select each one when we know what the parameter list is. That's how we identify it. We say, well, this one's got 2 pointer parameters. This one's got 3 parameters, 2 of which are pointers, one's an integer, etc., etc. So we can select from a list of function pointers based upon the parameter, but that array is nevertheless an array of pointers. Now, if we want to add one, you asked about DLLs, I think, last time. If we want to add one, how should we do that? How should we deploy it? Pretend that we are Microsoft and we are deploying a new library for some new version of something that Microsoft is putting out. You've already purchased it, and now you say, well, we've got this new version, and what we want you to do is to remove the old one and install the new one, because the new one has 3 additional functions. Is that what they do? No. They send you an update that actually doesn't change any of your applications at all. Leaves your applications completely alone. But the new functionality comes into play because this DLL, we've got a new DLL, or we have an updated DLL, which is a set of dynamic pointers. We get to that DLL via dynamic pointers that point to a different function than it did before. Is that clear? All we need is the name of the function. We need a pointer to it. And we can introduce brand new functionality. Brand new functionality. Okay. Are you convinced that this data structure, called a ragged edged array, sometimes called there's a lot of words, a lot of different terms for it in any event. I can't think of the one that I wanted right now. Sorry, I'll probably think of it in a second. So are you convinced? We need more examples of this, of why this is important. I can launch into some others. No? Okay. All right, we'll get off of that topic. Before we leave the topic, I want you to look at this particular. I'm going to shut this other one down. This is, by the way, OpenGL. Is that just a bad drawing?
Refresh rate.
What is refresh rate slow? Actually, that's a purposeful effect. It's a purposeful effect. Remember the torus that was over there that was spinning, and it was kind of shaded, but it was pretty well focused. It wasn't blurred. This is a purposeful effect applied to the torus as it moves. And it's supposed to give, I don't know if it does, but it's supposed to give kind of an idea of a blurring as it's moving forward. Almost like it's too fast, or maybe it's, oh, the refresh rate on that machine's really bad. We want it to look that way. In any event, a blurring idea is an actual effect that we can program into this, this routine. But the torus is the same torus as we had before, as in a whole bunch of examples here. But this torus has some special code dumped into the card itself, and the torus then, on the fly, in real time, is being modified not by the CPU, but by the GPU. Okay? So we are applying a C++ program to the geometry that's displayed, that's contained in the GPU, displayed in the card itself. We're applying a C++ program to morph it in some way or another. In this case, blurring it. Okay? The idea here is really a pretty cool one, where we take a program, C program, and we actually, when we compile this program, another C program that isn't compiled but is treated as a text string, a long text string, is submitted to the graphics processor. The graphics card itself has a C++ compiler on it. You got that? The graphics card itself has a C++ compiler on it. The only way you can provide that compiler source code is by sending it through another program as text. Is that clear? You've heard of shaders?
Yep.
That's how shaders are implemented on a particular graphics card. You generate C code, fairly simple C code. The blur that we just saw is a fairly simple set of C code instructions, C++ code instructions, that then are processed in real time as we are running it by the graphics processor. Okay, well, we digress. Let's come back to this stuff, which is more